Welcome. This is the second lecture of the course Fundamentals of Game Development, and like it has been tradition now with the restrictions on campus usage, I put the camera on for the first slide so you can see who I am, and if you for some reason need to look up me from the campus at some time, you at least know what I look like. So, as said earlier on the last lecture, I'm Associate Professor Jussi Kasurinen. I'm also the Adjunct Professor of Entertainment Software Engineering, so I am the games guy at LUT University and in our software engineering department. So if you have any questions or want to talk about game development or doing your master's thesis topic about something related to games and entertainment industry, please look me up. I will be the person to help you to get started on these sort of things. But let's move to today's agenda. So today's agenda will be twofold. First, we are going to go through some fundamental aspects about game development tools. So what types of tools usually are associated with game development work, and also what sort of tools you might want to check out if you are interested in doing a game development work in an industry. Also, we will be looking into 7 different real-life game studios and what sort of tools they are using, and what sort of things and technologies are important for the game studio. There's some differences between startups and established companies, so you also might want to consider that aspect if you are interested in working in the games industry one day. From the game development, we'll also switch to game design principles. So the task for you all on this course is to create your own game. So on the latter part of this lecture, we will be talking about the game design principles, how you can get started with your own game design, and again, look into a real examples on how game studios design their products. Overall, today's idea or the point of this lecture is to give you some ideas on what sort of tools you might want to learn or what sort of things you want to emphasize when you are looking out for new skills, and also help you get started with the game design work for your own game product, and also get an understanding on how the industry operates in general when they are doing designs for their new products. So overall, there's obviously huge amount of information on today's agenda. And this also means that we can't go into very small details on this lecture, but still to give you some ideas on what tools we are talking about when I'm mentioning game development tools or game development ecosystems or platforms, and also how game design in general happens, because this is something that differs quite much actually from the software industry and software engineering work and software engineering design work when we are comparing the software industry and games industry against each other. So let's start with the development tools. So overall, this doesn't only include things like programming tools or things that we use to write and edit or test source code. The development tools also cover all the other things that are required for the game project to be successful. This obviously means communications tools or work divisioning tools and all the other things that are required for the game development process to happen and the game development team or the organization to function as a development team or group doing their first or the second or the end game. And let's see what sort of things there are and how they might differ from the software development tools in general. Obviously, this is a slide I usually show in almost all of these lectures because this is something that's really important, and this is actually the cornerstone of this entire course. So game development and software development actually share some common features. This is a given fact because the games and game services or anything related to entertainment software engineering is also a product or service which has been designed and developed, and someone has done programming work or software development to make the game function in a computer setting or mobile phones or wherever it's running. So of course this also means that there will be a wealth of similar tools. Actually, on my personal opinion, working with the both industries, there are actually more things in common that most people in the either industry willingly admit. Well, of course, because the software industry doesn't really want to admit that they sometimes do very ad hoc work, and on the other hand, the games industry doesn't want to show itself as a software developers, but with a small twist. Basically, the design work has some similarities. Of course, the game design is something that's completely different from collecting requirements for making a new service or product, but nevertheless the design work needs to happen, and the design work needs to follow the same technical restrictions as most of the software development work, because of course we are running the games in the same hardware setups or the same hardware environments than most of the software products in general. Also, the development work, considering programming tasks, is almost basically the same. We select programming language, whether it's C++, Java, or some web development framework or whatever it is. It's still programming work. So that's given. And actually, considering the development process, the continuous delivery model is actually something that's been used both by the software and games industry. Of course, with mobile games, the continuous delivery is something that is more or less a thing that needs to happen, because most of the games are given as a free applications, and then you buy content. And if you run out of content, then you are not buying stuff anymore, or you can't sell anything to a person who has no longer interest on your product, whether it's that they didn't have one to begin with, or because they have already seen and done everything available. So considering that, the continuous delivery model and all the other continuous X models are actually something that's shared by both industries. The software developers are going towards that because of the software as a service thing, and also because the software systems which are in cloud can be deployed, and they can take a rollback on the bad patches or bad fixes and stuff like that. But also the game developers who inherently have to work with the mobile environments and also with the modern game consoles, or well, direct download services like Steam. This is something that can be done. If something is broken, then we can fix it, or roll back on a broken thing and make something that works instead. One of the best examples being the Red Dead Redemption 2 multiplayer mode, which has been known to be broken several times already, but every time it's broken, there's always the option of trying to fix it and break it more, or roll back on the changes and then just try to do something else. So it's more or less a living product or living service, which isn't set in stone, because the developers are doing changes to the product throughout its life cycle. Of course, also tools, and the tools that are used for testing and the testing work in principle are the same. Of course, the testing has different emphasis on other things, but in general, the software and game development projects all follow the same ideas: in time, in budget, with the features and with the quality. This of course means that also the tools to manage or steer the development work or the development process are also more or less the same, because even the development process itself can be more or less the same. So obviously, against software development, with the games there's always some differences. For example, you have to have emphasis on customers and markets, because we are not providing something that is inherently useful or generates money or saves time or something. In fact, we are making products that more or less waste time to provide the customer with something they are interested in and provide them entertainment or a user experience they wish to have for the money they are using. This of course means also that there's no ready-made designs or mandatory decisions which dictate what we are actually doing. So if we can design anything, then our story can be about anything ever. This also means that, of course, there is no set rules. For example, if you are making a web store or making a application you can use to see where the buses are and buy tickets and stuff like that, of course you have already ready-made designs and you have some mandatory decisions that needs to happen in a certain way. But of course with games there is really not that type of things. You are not restricted by the reality in most of the time, unless we are talking about technical requirements, which unfortunately still somewhat hamper the more crazier or wilder ideas. And this is actually something that's also related to the design work. So of course, with the game development or game design, we have an artistic vision of what we want, whether it's the theme or the characters or whatever it is. It's actually something that can be wildly abstract or full or complete fantasy or science fiction, something that really doesn't exist or even can exist in our normal physical realm. So some designers are talking about the design work or the game development work that we are actually making dreams into reality or making dreams into interactive stories or interactive worlds where we can make things or do things and see how the environment or the world interacts with us. Of course, one of my favorite points on this artistic vision is that if we are talking something like a Katamari Damacy games, where the basic idea is that we are running this small elf-like prince or his or her cousins, and the only thing they are doing that they are rolling a ball, collecting things and making it into this huge katamari, which is just a collection of things. We roll over buildings, people, collect nails, even some small tools, animals, whatever. Well, at the last stages, even oceans or countries or even stars and stuff like that. So basically completely crazy fever dream, but it's actually something that was made into reality. With the software development tools, doing the implementation of the design ideas, which were completely crazy. But on the other side of the coin, even if the design work is something that comes from the imagination, or more crudely said, also from the business decisions, if we are running a company doing games, the tools are not necessarily that different. We still use the same Microsoft or open source or whatever tools to do the development work, and we use the same testing suites to do testing work. We use the same deployment suites to do deployment into cloud systems. We still do the same container-based or stateless machines or stateless web services to implement all the back-end stuff, and the front-end stuff is developed with the game engine or something like that. So basically we are using the same product things to make the games than we use to make the software. And of course, even though the sound design is something that's that's very different from the software development, the sound design is something that's fairly similar, or actually the same tools that we already use, for example, in music industry, or when we are making movies or sound effects, or even something more everyday items like interactive help or interactive counters, or in elevators you get the bling and all the other sound effects implicating that something has happened. So this isn't, while sound design or sound effect design is something that's not inherently software development in a sense, it's in any way something that the people making software products or services or some types of products and services are still working with. Overall, there's also a couple of programming aspects that has emphasis on them. The client-to-client multiplayer system, real-time multiplayer systems, or 3D mathematics are actually fairly huge thing in game development. Also, artificial intelligence in a sense. The game AI design and programming work isn't actually a real artificial intelligence in most of the cases. The system isn't capable of having an artificial thought, but it's an AI which can play the game or understands the rules enough or mimics the player enough so that it gives you an opponent which might not seem like it's cheating or using its own rules, but it's still something that you have to be able to create. And while the game AI is far away from the true AI systems or smart systems, it's still design work and programming work in artificial intelligence. And overall, considering the user experience, is the game fun or is the user experience something that we want to provide is of course always the one of the key things in the development, in the design, and also in the testing work. So of course these things are something that we have to design for, we have to develop for, and we have to test for. So going further into the actual question that what do you actually need to make games? The shortest possible version I've heard of this is basically a computer, a developer, and a place to sit. Because fundamentally, the games can be very simplistic computer software, products of computer software. On the other hand, if you have multi-talented developer, it's completely possible that they more or less make the products by themselves. But of course, immediately, if you want to have some sort of a professional development project, you probably want to hire people who are more skilled than you at drawing things or animating things or doing the technical optimization of things or selling things or working with things. From the technical point of view, of course, the computer by itself isn't going to cut it. More or less, we need to have game designs, game designers and game design documents and game design scale that we need to have prototypes. We need to test the proof of concept. We need to do feasibility testing. So we need to have game designs for all the different parts of the product to understand and see that can it actually be done and does it actually work. We also need graphics. We need animation artists to create us an industrial or industry level, professional level product, because not everyone is capable of producing high quality animations or high quality graphics or high quality design. Also considering that we would probably also want to have a person who is capable of working with the theme or the style required for this type of product. Of course, we need to have programmers, so we need to have programming tools, development engines, development environment, software ecosystems, all the other normal stuff you would expect when you are doing a programming and program development work. And of course, you need test audiences, so you need to have test cases, so you need to do some sort of a plan on how to check out that everything in your product works. Finally, of course, besides doing testing work, doing feasibility testing, doing design work and development work, writing the code, we also need other programming tools like version control tools or other management tools to ensure that we actually can work together and the team isn't actually using its resources or effort doing, for example, the same things several times. So, and understanding who is doing what and dividing the work so that everything gets done, but no redundant work is done during the project. Also, if we go to commercial projects,
We also tend to use auxiliary services such as physics libraries to do optimized calculations, or by that we need to have our own person who is capable of creating such subsystems, or using or incorporating or embedding some sort of payment management system so that our customers can make these microtransactions and other stuff, buy things. Also cloud services for saving the user profiles, the user safe games, so on and so on. But obviously, if we select the platform correctly, for example, mobile systems, we already have several options for payment management and cloud services provided by the platform itself. So basically, we are just using the APIs or other actually access routes to use these services without actually having to develop them by ourselves, unless we are a huge company and want to do it anyway. So, of course, there's also different things that the different types of game studios tend to focus on. For example, large game studios. They want to have focused professionals because they have already several people working for them. So they want to have absolutely the best people for that role or that job they can possibly find. Meaning that if the startup companies are looking for all-around experts, meaning that you have to be competent on several things, and one thing is the one you are very good at, the actual game studios tend to want to have the very high level professionals, whether it's animation, whether it's graphics, sales, or programming work. From the software engineering perspective, this is actually very interesting because startup companies are looking for all-around experts, and they might be actually very happy to get a software developer for games who is capable of working with Unreal Engine and maybe doing some small optimization or adding extra scripts to optimize or make the game or make some things happen faster. Whereas the game studios themselves tend to look for high-level professionals, and actually some of the companies list that if you know how to do C programming or low-level C programming, optimizing the subroutines which do the calculations, then you are the correct person for us. More or less, the studios say that whether you are a art director or developer or artist or musician or a business person, you need to have talent and passion for this work. Of course, some of this is a marketing gimmick and bullshit, but what they actually mean is that they have no use for adequate or poor or less than average talent. They want to hire very specialized people who are very capable in the one thing they are doing. And if we consider some tools these sort of people or these roles require, for example, the things listed here, Photoshop, 3D Studio, even Blender, the game engines, Unity, Unreal, or if we are working with the some web game development and some other web game engine platform or ecosystem, sound editing, Audacity for sound editing work. And if we want to focus on exact programming languages, then of course Java, C#, C++ are even things that are very common for all the game development projects. This more or less because, like mentioned earlier, the game development and software development isn't that different. For animation, for drawing, for artists, the Photoshop, 3D Studio, Blender are not completely normal tools they use to work. Similarly, in sound editing, Audacity is something that's very popular also because it's an open source tool. And the game engines, Unity, Unreal, some other web game engine tools, game engine ecosystems are things that make it easier to express your designs or get things working. But underneath everything, underneath the layers and layers of abstractions and tools, if you want to learn programming language, which makes you a game developer, that's Java, C#, C++ even. At least Java is something that's very, very common in almost all game engines except Java code or some bastardization of Java. So considering that you don't need to necessarily just rely on my opinions here, we have an example of developer ecosystems in 7 different game studios. This data was collected from our earlier studies into how game companies actually function, and also served as a sort of a way to guideline for how we wanted to create this course. So on all these organizations, we interviewed several different people. These themes or these roles we just mentioned, we talked with team leaders, project managers, developers, testers, upper management or the owner of the startup company, and also lead designers or art designers if the company was large enough so that the art designer or art lead was someone else than doing the actual lead designer. And with them, we talked about several different aspects on how these organizations develop their games. From the viewpoint of quality assurance, from the viewpoint of development, from the viewpoint of management, marketing, all the other things, to understand how these organizations actually work. And these were the companies we were working with. Of course, due to confidentiality reasons, I can't give you names, but I can tell you that all these companies were working in Northern Europe, some of them in one country, some of them in several, and all of these organizations had game development as their main business source or main source of revenue. So we had PC developers, we had console developers, we had mobile platform developers, and we had a company which was focusing heavily on browser games. Three of them were new startups making their first games or making their first real commercial product, being earlier somewhat of a hobbyist group or releasing something not as a completely serious commercial product. Now, 2 of the companies were very established organizations which had more than 5 products. Actually, the largest and oldest one had more than 10 released products on all the different platforms which you could imagine at that point for game development. So Xbox, PlayStation, PC, Steam, whatever. And the rest of the companies were somewhere in between. So overall, the production team sizes varied from less than 10 people, actually less than 5 people, to the largest organization having almost 50 own persons and employing over 100 people as a third-party subcontractors. So basically, huge variance of organizations. So how do these different organizations develop their software or develop their games and products? Well, one of the important observations was that actually when this interview was done, these huge omnipresent game engines were more or less a new thing. World was about to enter into the stage where some game engines like Unity or Unreal or even Havoc, which was a big thing before Unity, were dominant systems in the industry. Actually, it used to be so that the game development studios had to make their own game engines because usually the existing engines were extensible enough to use. On the other hand, most of the organizations didn't really care what the developer used. As long as it was compatible with the project, the artists, the developers, the programmers could use their own tools. Personal preference on what they want to do, as long as it's compatible with everything else we have. And usually the problems with the products, especially in the more established companies, was that actually the tools themselves were a bit restricted. There should be more extension modules so that there could be more features or ability to do better version control, for example. There's bugs in the system, in the software, meaning that when we are trying to find out what is going on, it's sometimes difficult to understand if the bug is caused by the game engine or physics library subsystem or our own programming work. So this is something that actually cost a lot of time, and in overall, the design method for the organization was usually using some sort of documents and prototypes, meaning that we test everything with prototypes and make a design based on the prototypes so that we have something that's solid, but also something that can be quickly thrown together if we want to try out a new idea. Also, most organizations had some form of actual knowledge transfer system, whether it's a management tool or just email chains or something. Most organizations had at least some form of managed communications. But of course, this is something that should be expected because it's also the same with the software developing organizations. So, what sort of tools these organizations then need? Well, one of the important things that we understood quickly was that there's actually two phases of game development. There's the pre-production stage where we are trying out things. We are testing different ideas, we are testing different concepts, technologies, trying to find out the new best project ever. And then there's the production implementation phase where we are developing the product. So something that we have already committed to and want to make sure that it works and that it exists, and so that we can later put it available somewhere and make money out of it. So of course this means that on the first design stages, there's actually differences in what is important. For example, the development tools, they are more about doing a test graphics or putting together a test prototype. Whereas when you go into the production, it's more important to have your tools selected so that actually things function, and these sort of problems where you need to do debugging or fix bugs both from your own product and also on the third-party tools is something that shouldn't be happening anymore. Of course, this also means that if we as an organization commit to some project or some production, then it means that we also test out the different documentation and cloud services and file sharing services before we start to work. Because, for example, migrating version control services or the project repositories or ticketing services or anything into another system during the production cycle would just cost us money and be very inefficient way of doing things. So in general, the game engines and other complex systems are used because they save time and money. Of course, this only goes so far. The game engine and other complex systems or platforms are used as long as we have need for them. For example, larger game studios tend to do mass optimization or create their own game engine so that they have more say on how certain things behave, or they want to have easier optimization, or they want to have all full control and all control on the direction of the engine on their own hands. But it doesn't mean that you have to be a C# or C optimization programmer. You can have a completely valid job in games industry by just being a sort of a tool user, meaning that if you are drawing something or animating something, you are obviously going to be using animation or drawing tools. But even if you are a game developer, being a very good with some game engine is also a valid strategy, although it might be easier to get employed or find your own place if you also at the same time know how to optimize subroutines or optimize computational routines with the C programming language. Of course, on the games also, because we want to give the best impressions. We want the games to look nice. We want the games to feel something that they should be. The artists usually are allowed to use whatever tools they want. Sometimes even the developers, as long as it compiles and it's compatible with the other systems the organization is using. But mostly the tool selection principles are more or less that the artists use what they are most comfortable with, and also if it's possible, the organizations don't have very strict rules on what sort of an editing tool you should have, or that everyone uses Visual Studio now, or everyone uses NetBeans or whatever to do the development work, because the only thing that matters is that it's compatible with everyone else's work. So use the tools you can. And finally, also, if you are, whatever you are using, you need to be able to test out new ideas. So if you want to develop games, you need to have fast prototypes. And to have fast prototypes, you need to have sophisticated tools. So you can test out ideas, ways to move, ways to control things, attributes, all those different things, because it's a waste of money and your time to implement something that actually isn't that funny or doesn't work or has to be got from the end product. So using fast prototypes to explore the different options and solutions for designs or technical feasibility is actually a very, very needed feature. Also, this in general means that if you are making a tool for game developing company or games industry, you need to have easy prototyping and ability to design while implementing. Because most games are designed while they are developed or while they are implemented. Because like said earlier, we are making someone's dream into a reality. So we need to be able to test out what sort of things work and what sort of things doesn't. And this is actually something that the tools always should allow. Overall, the tools that are aimed at the games industry, tools that are used by the games industry without many or much usage in the software area, the most usual problems are that there's a number of bugs then, or that the user interface design is bad and difficult. The tool makes itself unnecessarily complicated by hiding things or showing things so that it's not very intuitive. For example, I know that Unity game engine is something that has a very poor reputation because they keep changing things. And it's actually almost impossible to use at some stages because the things move around so much that even during one development cycle of 6 months, developing one game, mobile game from start to finish, the Unity game engine used to have drastic changes in them. So it was a bit of a hindrance, or even a bad thing for the organization itself. So because it didn't do feature freeze, or it didn't do long-term support. It almost started to hinder itself by competing against its own old versions of itself. And for example, on this particular course, the Unity engine was used in more prominent role, but because it kept changing and changing and changing, meaning that for every year, all the demonstrations, all the examples, all the other things were broken because things had changed. And this is something that irritated me, but you can imagine how this irritates someone who is actually working for a game studio and trying to make a professional game out of it. So many organizations also aren't that large. Even if we are talking about huge organizations which had tens and counting subcontractors, hundreds of people working for them, there was a small project management tool usage here and there, but usually the teams are small enough that the formal work divisioning tools, ticketing systems, these sort of things aren't necessarily needed. The teams are organized in a ways that there's teams responsible for different things and they do their own thing. And when they get that thing done, then they compare and try to integrate things into each other. And overall, as this is very important observation for you. So before about 2010, most game developing studios were actually developing also their own engines because there were no universal or well tailorable engines available anywhere. But this is something that has ceased to exist. But on the other hand, if you are a large game studio which needs to push the envelope further and further and further and make innovation happen, these people actually do need to do programming work, not game development with some existing engine. So if you are a software engineer who has good skills on C, C++ programming, understanding of how low-level systems, for example, based on Unix and system programming work, then you actually are already a person who has a skill set which is very valuable to the games industry. So this also is something that might surprise some of the people. If you are a very good C programmer, you actually are very attractive to some game studio companies. So that's for the software development tools or software development skills, more or less. So let's take a look into the basics of game design. This is something that we already touched upon a bit on the earlier lecture last week, but let's look through some couple of other pointers to get you started on how to design your own games or how to get started with your own game design ideas. So first of all, this is something that I really need to emphasize for you. If you cannot express your great idea with the maximum of 3 slides and 5 minutes, it is a bad idea. This is something that was told to me by one of the lead designers of a game series which went to sell platinum in Asia, so I guess that person actually knows what they are talking about. But this is actually a very good summary or rule of thumb if you are designing something, especially considering that on this course we want to keep the design simple and neat because we don't have that much time or resources to do these things anyway. So unless you can express your idea with maximum of 3 slides and 5 minutes, then you might want to revisit or rethink your idea. Also, if we go into the real world, There is a notation that sometimes a stupidly simplistic idea is something that works very well, whereas something that sounds very interesting and sounds very engaging is actually quite boring and bad. So this also is something, is also a reason why the prototyping approaches are used. Of course, you need to start with an idea which is easy to explain and simple to show, but also you need to test out things beforehand, because sometimes boring ideas make great games and great ideas make boring games, and that's just something that's a fact of life. So, how do we then design the games? Well, considering these organizations I just mentioned, these 7 game studios, combined can have something like 30 commercial products with them. So there has been several times when the game design process has been followed through. Unfortunately, there is no silver bullet here. Most game designs are actually just concepts that just came out of someone's imaginations. Some individual came up with an idea, or some team worked in a pitching contest, or some other way came up with a plan based on media trend, joke, some concept, consider that this might be interesting. This is how most of the game designs actually happen. Someone gets an idea, makes a prototype or a small pitching deck, a couple of concept art graphs, and there you have it. So basically, if you don't have any way or any idea on how to get started, you might want to consider, how do I make a game? How do I make a funny game? How do I make exciting thing, or something that's new, novel, interesting, or something that works against the user expectations, so that it's actually something that gives us the look and feel of the game. And it doesn't have to be something that's just like light switch going on in your head. It doesn't have to be that. On this example, for example, I have made a short work of brainstorming session or ideas, a summary of brainstorming session or ideas pitching contest, which steers an idea towards something that can be implemented as a game. So we start with a simple idea. We have a car and it's driving down the road in a crowded city center. Okay, we know that this is actually something that can already exist as a game, so it can be a road racing game. But how about we make the car an erratic elephant who tries to avoid damaging the city? So it's kind of a runaway game, runaway elephant game. Okay, that sounds nice. But how about if we give that elephant a purpose? We make the elephant try to run down the city and try in a crowded city center, avoid damage, and we also don't want to make the game violent. So let's remove people and let's put pigeons on instead of them. So the pigeons are the flying rats of all the metropolitan cities. People tolerate things more on them than actual humans. So of course, we still have animals in it, so let's make it a cartoony game. So it's not actual animal use in graphic details, the game. It's something more funnier or cartoony. So we have a cartoon elephant running down the pigeons in a crowded city center. So why did we have an elephant running down the city center? So let's put a circus in. Let's put clowns to chase down the player elephant, and the player elephant is chasing down the pigeons who are in the city center. Of course, this is already something that might be funny, but let's make it a bit weirder. Let's make the light posts and other other signs, living things, which are trying to trample or beat the elephant down somehow. So, okay, now we have a cartoon elephant who is running down the pigeons in a crowded city center while avoiding traps set by a bunch of clowns and avoiding being trampled and beaten by the light posts and all the signs and the other suitable objects of the city. So, okay, now things are happening. So let's add a story on top of it. So we have a cartoon elephant which is running down the pigeons in a crowded city center while avoiding traps set by a bunch of clowns and avoiding being trampled and beaten by the light post-like stick figures in an open city landscape run crazy by a yodeling supervillain, robbing the place with the pigeons and using the light post stick figures as his guards. And our elephant is hunting them for justice. And there you have it. That's a game design. That's your initial draft. Now let's make a couple of ideas. Let's make a ball running through the city maze, running over things, add some other things, make a couple of test graphics, see what would look nice, what would look cartoony, make a graphics portfolio of things that you want to have the game look and feel, and there you have it. You have nailed it, the first initial game design. So it doesn't have to be difficult, and it doesn't have to be very interesting idea. So the initial idea can be where we have a car driving down the road in a city center, stuck in the traffic. And then finally, we have a yodeling supervillain, and we are using an elephant to hunt down pigeons. So actually, that example might sound a bit, well, stupid really, but it's not that far from actual game design process. Of course, if we have a commercial aspect in the game design, it also means that it has to have some connection to the, or we have to have some idea on what might sell, what our customers are expecting, what sort of things are considered interesting and what sort of things are considered old news right now. Of course, if we have commercial interest in a game design, we cannot usually just hope that our crazy idea works. We need to have something that's proven, or that we have a couple of prototypes that our test audiences like something, and we go towards that direction. So basically the same idea, but with a bit more conservative steps. Of course, considering the games industry, what's today's superhit is tomorrow's old news. So of course, new ideas are always welcome, but of course, realistically, the game studios are not that liberal and wild with their ideas. You tend to copy your competition or tend to follow the same similar paths and similar ideas. So you come up with the similar types of products because they all not only because they are easy to make, but because they seem to sell. They ensure that you have a certain audience, and it's not a gamble to create such a product. Well, it is, but not as much of a gamble. But of course, this being a university course, and we don't have monetary assets considered here, well, not besides the game design plan anyway, I'd hardly recommend and encourage you to use the go crazy design principle. So make something that's funny, that's something that's new, that's novel. Don't make a 15th rollerball with a small changes in theme. Try to do something completely crazy and bonkers, because that's also some way that you can enjoy this course more. Make some designs that are actually new and interesting and novel, because you can continue with that idea, or you can continue with these sort of approaches later on, and you have the entire rest of your life to design the Wall of Call of Medal of Honor of Duty of Justice 15 games. And of course, considering this from the perspective of real life, of course, if we have to design a real product, especially if we are a startup, we have to go with what pays, what makes us money, what's most likely to reach our target audience, and if we make it well enough, feel just liked enough, and then when we have some success underneath our in our portfolio or in our existing product catalog, then we might start to do our own things and different things. Of course, there's a couple of more small differences on the game design and software design, which are worthwhile to mention. Of course, game developers are, or they consider themselves to work in a creative industry. Software engineers, software developers in software industry don't tend to think that, or they might think that solving problems with the programming languages might be creative problem solving, but actually the industry itself isn't that creative. But the game developers are always considering themselves to be in creative industry, but the key word here is industry. They aren't artists for art's sake. They are trying to make money. They are trying to make profitable product. If they happen to make something that's creative and artistic, that's also nice. But if you are present the dilemma of having a huge amount of money out of your products, or having products that are very famous but don't make you that much money, most of the people working in the games industry also always think that it's the money that's the thing, because they are not doing art for art's sake. And of course, the idea with this is that, of course, the creative artistic merits, game of the year awards, these sort of things are always nice, and but they are not necessarily things that are sought after if we can make money or make the game studio a success without them. Also, of course, because the organizations are making designs that need to reflect the user experience, that's something that the users might want, or that is something that the users expect. It also means that the technical design relies on prototypes and the game concepts are constantly challenged. The game companies, game studios even expect that things change at the late stages of development, or that they necessarily don't ever have a complete design. They just add things which makes the game or the product towards something that the audiences seem to like, because the game development is more or less continuous delivery. So not only are the late changes allowed, they are expected that, and sometimes even the games are launched in a way that you can select a couple of best branches for further development if you are not certain on which way the game design should go. And of course, considering the games industry in a whole, the game products are designed with creative processes which actually are rather close to the similar approaches that, for example, movies take. We test a couple of actors, we test a couple of ideas, we test a couple of scripts, and then we finally commit to certain script, certain manuscript, certain game design document with certain features, with certain actors, with certain characters and art styles, for example. So in this sense, the games industry, yes, it's artistic work, and game products are art in a sense, but more or less the games are not art for art's sake. They are fun products, fun services, and the organizations are making them to make money and be able to make more games or make more money, whatever. But still, the idea was that the organizations try to develop a fun product or the product that their customers are looking for. And if it's art, then it's also a nice thing to have, but it's not always necessary. But in a sense, yes, the games and movies are similar products in design. So taking a quick look, because, well, this isn't very important for this lecture, but if we take a quick look at how the games are designed by these same case studios we watched earlier, the design phase, it's almost always something that it's good mechanics, concept demos, test mechanics, design of all things, make something that's marketable in the future. And the design method is always, well, idea pitching, prototypes, vision group work, prototypes, vision, brainstorming, prototypes and vision. So basically, there's no silver bullet here. The idea is to have this sort of an core concept or quick abstract or idea, test out with a prototype if it works, and if it works or seems to work, then we might want to commit to it. Basically, all organizations have major changes in their products. Only a couple of companies said that they only had minor changes, but on the other hand, they were also making a product that was almost, that was more or less something that was fairly simple thing to do, platformers. I think that the one organization was making a electric version of an existing board game. So of course you'd expect that that doesn't get that many changes because the gameplay and the rules elements are already there. So basically, also who designs your game is, well, usually the company has a lead designer, or it's the producer who is also the project manager in a smaller productions or smaller game studios, who is the person making the design. And of course, all organizations more or less are going with the money if they have to select if they want to innovate or if they want to have money. So basically, it means that if we are talking about commercial game development, we are also talking about the situation where we need to really understand who our customers are, what sort of products do they want, what sort of games do they expect, what sort of things interest them. Of course, there's several places in the history where this has gone wrong. For example, LucasArts Games decided to stop making adventure games because they found out that the average 14 to 25 male target audience doesn't actually care about adventure games. And this was the game studio that made the best adventure games in the genre. So of course there's missteps here and there. For example, in this case, the game studio didn't understand that they are the niche owner. Even if the niche isn't something that's majorly popular, you are still making money out of it because you are the niche owner. But of course, this is more or less marketing things. But if we look for the sources of innovation here, well, movies, trends, success stories, prior experiences, old games, TV, books, prior experiences, competition analysis. So basically, there is a saying that the biggest or the greatest form of flattery is stealing someone else's work. So basically, the game designs in a commercial design work has to rely on something that probably sells or something that has known qualities in it. But if we are working with the designs on this sort of university course, we can go crazy. But of course, this is something that doesn't necessarily work in the games industry. So a couple of ideas on how you should start working with your game. Now that if you follow this go crazy style of brainstorming approach, you probably come up with some couple of ideas on what sort of things you want to have. But how about the content itself? Of course, almost always you want to design things based on this activity cycle. This is actually something that's lifted directly from our gamification and gameful design plan, but it also, of course, means that this is something that's fairly fundamental thing in user experience design or game design. So motivation comes from taking an action which is meaningful in the game context, and the action gives you feedback which somehow alters your usability or user experience, or gives you some positive reinforcement that you are doing useful things, which generates you motivation to do further actions and so on and so on. So basically, if you destroy the monsters, you get the loot, you get new, which allows you to buy new equipment, which makes it possible that you can kill bigger monsters, and so that you get loot and you can get new weapons and so on and so on. So it might seem simplistic here, but this is more or less how the user experience is built. You have a motivation to do something, you do it, and you get feedback, which creates a positively reinforcing cycle. Also, with this cycle, you need the balance act, the flow between the boredom and anxiety. We all know that there are super difficult games, for example, for game consoles. Dark Souls are very well known for this sort of high difficulty aspects. On the other hand, if we are playing some children's games, there's actually a possibility that the games are very simplistic itself. But of course, you need to select your audiences to understand what you are making. Regardless of what your target audience is, you are also always working against this flow. So you are motivating your user to take an action and providing feedback so that they will do something else. Of course, the player gets skills, player gets more experience, player as a person, not the character they are playing, but the person knows how the game works and expects it to challenge the player more. So this means that the game has to offer new things, new enemies, new abilities, new levels, new challenges in general, so that the player doesn't get bored. If the game gets too samey or there's not new content to unlock, of course the player gets bored. Or at the same time, if the game just throws the player in the deep end of the pool and says that sink or swim, then the player, of course, gets frustrated and anxious because the game is too difficult. They don't survive. So you have to be able to find the flow, the sweet spot for how your game progresses from the first tutorial levels towards the last challenges before the game ends. And this is something that if you want to read more about the game design principles, is called progression stairs. So the game teaches you for a couple of levels or the early part of the level ways to do new things. It allows you to rest, take your time, prepare for the next boss, and then you have a boss fight, which is a trial. If you pass it, then you are allowed to rest again. You are taught a couple of more new things. You are given possibility to prepare for the next fight, and so on and so on. So the required effort increases, the difficulty increases, and if the player is following the path, at least to some way, in the way which you designed it, then the player gets more skilled, experienced, and the flow happens or not. If the player finds the game too challenging or too easy, then it's just the player preferences are not matching with your product or something else. But this is how it happens if it ever happens. Finally, when you are making the game design, so of course you need to consider that you need to have some interaction. You need to have some way to enable the flow. You need to have some sort of way to make the levels progress, but also you of course need to have the initial concept, whether it's the elephant in the city center or whatever it is. When you get this idea, you need to write down these aspects: the general theme, the main characters, what the genre of your game will be. What are the important features? Do you have story? If you have, what it is, and if you want to try something very strange or very challenging, what sort of technical decisions do you have? For example, do you want to control the game only by camera or shaking the phone or whatever you are doing? Also, in the course context, what are the mechanics that you should learn before you can implement this? What would be the tutorials that would actually benefit your design so that you actually get something that's worthwhile from the tutorial projects so that you can implement your own game with the same ideas and only just learn a couple of more things. So these are the things that you should take into account when you are selecting the tutorial projects, and also at the same time thinking that what would be the game you are implementing on this course. So go take that template, it's there. Don't write on that one, copy your own document and use that as a starting point. So what sort of things you need to get your own game done? And based on that, what tutorials you need so that you have technical skills to start working on the game, and then also learn more. What are the things that you need to learn more by yourself so that you actually get the game implemented before end of the November, when we have a deadline for all the deliverables. So that's that. So this was the second lecture of fundamentals of game development. We talked about the different game development tools. We talked about how games are designed in general. So hopefully you found this information useful, and you can get started on your own game design. Also get some ideas on what sort of tutorials you should be doing, what sort of things you should learn, or collect a list of things that you need so that your game will be a great success and you can continue working on it, or at least use your now new game development skills on the next Finnish Game Jam at the which usually is immediately after the new year in January. So thank you once again, and if you have anything to ask, send an email or send a message to the Moodle course page. And well, please contact the course assistant if you need some technical guidance. Please keep in mind that this is still a self-study course, so you just got some ideas on what sort of tools you might want to look into, how you might want to design your own game product. And we will, of course, help you if you run into troubles, but keep in mind that if you select very esoteric tools, the type of help you need is also very esoteric. So anyway, but thank you for listening for this. and see you at the next lecture.